Hello, hello, and welcome to a little review for KC3. Alright, let's get started. David rode his bike to the park. After staying at the park for a while, he continued his ride to the grocery store. The graph shown represents this situation. Let's identify the domain and range. Now, the domain has to do with the x-axis, which in this case are our minutes, so they happen right here. So I'm only going to look from left to right, depending on where my graph starts and stops. So my graph starts right here on the left, and then I trace my pen, it ends right here on the right. So it looks like we're going from 0 to 50 minutes. Let's do the same thing for range. Ranges are y's, and in this case, they're right here, they're miles. So now I'm looking at this graph again, and I'm looking from the bottom to the top of this graph. So I'm kind of looking at it sideways. I see that it starts at 0 on the bottom, and the top seems to be right here. So let's see, where is that? 2.5. So we start at 0 miles, and we end at 2.5. Now next, we are asked if the graph is increasing, decreasing, both, or constant. Well, I would say here that my graph is increasing because it is going up, and it has a constant interval. So I'll say the graph is increasing overall and has a constant interval. And I know it's increasing. I always go left to right. You trace your finger on your graph and you're seeing if it's going up or down. All right. For questions 2 through 4, we're going to determine whether each relationship represents a function. Number 2. So when we have a graph, what we do is we draw a vertical line and see if it passes the vertical line test. So here's a vertical line through the U shape of my graph, and it looks like I pass twice. This means not a function. Doesn't pass the vertical line test. So if that vertical line only crossed once, then it would be a function. All right, number 3 has a table. When we have a table, we look at just the x's for our domain, and it cannot repeat. So what we take a look here, it looks like my x's do not repeat. They're all different. So function x's don't repeat. Next, we take a look at number 4. For number 4, we have a map. Now, when we have a map, what we want to check again is the domain, and we want to make sure they're only having one arrow coming out of each domain. So it looks like this works. This is a function. One arrow out of each domain. Okay, onwards we go. Number 5, let's consider the sequence. Describe the pattern shown. All right, well, the pattern looks like it's getting larger by a row with one more dot. So this started off with 2 dots on the bottom, 3 dots, 4 dots. So it just keeps getting taller and taller with more dots on the bottom. So draw and describe the next 2 figures of the pattern. So if you want to draw them, you're welcome to do so. The one afterwards, so I guess the next would have 5 more dots on the bottom. Then it would have 6 more. All right, so Let's write a numeric sequence for the first 5 figures. So the first figure has 3. Then I add a row of 3, I have 6. I add a row of 4, I've got 10. So 3, 6, 10. Well, then in letter B, I wrote I would add a row of 5, 15. Then I said I'd add a row of 6, 21. Letter D asks us for the 10th number of the sequence. All right, so we got the first 5. Let's keep going till we have 10 numbers. So now I'm going to add 7. Then I'll add 8. Then I'll add 9. Then I'll add 10. That's 1, 2, 3, 55. So that's 9 terms. One more, 66. So 66 is the 10th number of my sequence. Number 6. Write the first 5 terms of an arithmetic sequence with a common difference of negative 2.2 and a first term of 0.2. First term of 0.2. First term means the first number in the pattern. Now the common difference of 2.2, negative 2.2, means we're going to be subtracting 2.2 each time. All right, let's whip out our calculators and do it. So first I subtract 2.2, negative 2. Subtract 2.2. Another subtraction. And one last one. I end at negative 8.6. All right, number 7 and 8. Identify each sequence as arithmetic or geometric and determine the common difference / common ratio for each one. All right, so first I'm going to test out and see if this pattern is arithmetic. If it's arithmetic, it has a common difference. What we do for that is we take the second term minus the first term. Let's do it. So 12 minus 48, that's negative 36. So if it's arithmetic, that means my pattern is to subtract 36. All right, well, I know it works for the first two because we used them. 12 minus 36 is not 3. All right, so it's not arithmetic. Well, that only leaves us one other option, that it's geometric, which is nice because none of them are neither. So geometric, but we still need to find the common ratio. So to find the common ratio, we take our second term divided by our first term. So 12 divided by 48. You will either get 1/4 or 0.25. They're the same thing. So that would be our common ratio. Whichever one you write down will be correct. All right, number 8. I have a pattern. Let's do the same thing. We start off by checking if it's arithmetic or geometric. I'm going to begin with the common difference to see if it's arithmetic. 11 minus 8, right? Second term minus first term. 11 minus 8 gives us 3, which means, oh, I forgot to write nope here, which means my pattern would be adding 3. Let's try it out. I know it works for the first two because that's what we used. 11 plus 3, that's 14. 14 plus 3, that's 17. 17 plus 3 is 20. So it's arithmetic, and my common difference is 3. All right, number 9. Let's write an explicit formula. Now this is an arithmetic sequence, and we can find that out by doing the common difference. I got ahead of myself. We're doing the second term minus the first term. Let's do it. Second minus first. And 1 minus 1/2 is 1/2. Or in your calculator, you might get 0.5. Let's test it out and pretend I didn't just give it away. 1 plus 1/2 is 3 halves. 3 halves plus a half is 2. Plus a half is 5 halves. Plus a half is 3. plus a half is 7 halves. So that is correct. Okay, now our explicit formula is an equals an minus 1 plus d. And d is, whoops, I did that backwards. This is our recursive formula. Haha. Never mind. Let's try that again. All right, Miss Gumin. I had an oopsie in my brains. It's A1. I just went on automatic. I'm sorry. Plus D n minus 1. Okay, so let's replace everything we have. A1 is actually our first term, so 1 half. Plus D is our pattern. What's our pattern? It's 1 half. And n minus 1 stays n minus 1. All right. Number 10 is our recursive formula. First, let's see if it's arithmetic or geometric. We need to check if we have a pattern. So we're going to take our second term minus our first term. Right. 0.17 minus 0.15 is 0.02. If it's arithmetic, that means each time we're adding 0.02. Let's try it out. 0.17 plus 0.02 is 0.19. Let me try it one more time. 0.19 plus 0.02 is 0.21. Awesome. It is arithmetic. Now our recursive formula is an equals an minus 1 plus d. And d is our common difference. Okay, let's do it. The n's stay as n's, but instead of plus d, I'll have plus 0.02. Success. Now number 11. Determine the 20th term in the sequence defined by this equation. In order to find the sequence, the 20th term of the sequence, we're going to take that 20 and we are going to plug it in to the n of my equation. This part goes right into your calculator and you get an answer of 59. Number 12. Barkey's Bakery sold 20 dog cakes during week 1 of operation, 27 during week 2, and 34 during week 3. If this pattern continues, let's fill in the table. All right, so we start off with 20, then 27, then 34. Now, we know it's a pattern. Let's find out what it is. To get from 20 to 27, we add 7. Let's see if that works. Yes. Okay, so let's keep adding 7. 34 plus 7 is 41, and 41 plus 7 is 48. Cool. Write an explicit or recursive formula. For the sake of this review, I will write both. So let's start off with the recursive. So for the recursive formula, it would be an equals an minus 1 plus d, our pattern. So plus 7. For explicit, this is actually the one I personally prefer. We begin with our first term plus our common difference, and then n minus 1. So either of those would be the correct answer. It's up to you which one you choose to use. Letter C asks us, use your formulas to predict the number of dog cakes the bakery will sell during week 12. So it's A12. What that's telling us is to take 12 and plug it into our formula. All right, that goes right into your calculator. And we have 97 dog cakes at the end of week 12. All right. I hope you found this useful. If you have any questions, please make sure to ask myself or anyone else that's helping you. Have a wonderful rest of your day. Bye.